Welcome to Keys Consumer Math and Personal Finance, Section 1.2, Percent. Percent is something that you have done in the past, but we're going to review it here because it is foundational to consumer math. A century has 100 years. There are 100 cents in a dollar. So what do you think cent means? Cent means 100, and percent means per 100 or for each 100. In other words, a percent is a ratio with the denominator of 100. So, knowing that 100% is a ratio with the denominator of 100, so we can rewrite it as 100 over 100, which equals 1. 100% means one whole, all of it. Now, a percent can be written as a percent, for example, 60%, as a decimal, or as a fraction. First, I'm going to write this as a fraction. 60% is the same thing as saying 60 over 100, because remember, a percent is a ratio with a denominator of 100. This can reduce to 6/10, which also reduces to 3/5. So 60% can be rewritten as a fraction of 60 over 100 or 3/5. The 60% can also be rewritten as a decimal. I'm going to start with the fraction again, 60 over 100. Because remember, a percent is a ratio with a denominator of 100. You would read this as 60/100. That's the same thing as saying 0.60, because that is 60/100, the 10th place, the 100th place. So 60% can be represented as a decimal as 0.6. Another way to think of it is percent means divided by 100. And when you divide anything by a factor of 10, you're going to move the decimal to the left as many zeros as there are. So when you divide 60 by 100, there are 2 zeros in 100. And so you could say 60% is the same as moving the decimal 2 places to the left, because you're dividing, to make it 0.60. Or just 0.6 is fine as well. When you go the other way, when you take 60/100 or 6/10 and you want to turn it into a percentage, you're going to multiply by 100. That means you're going to move the decimal to the right 2 places, and you're going to get 60%. So once again, when you change a percent to a decimal, you are dividing by 100, because percent means to divide by 100. You move the decimal 2 places to the left. When you take a decimal and turn it into a percent, you move the decimal place 2 places to the right. It's that simple. A common use of percentages in the life of a consumer is in borrowing money or investing money. When you borrow money, you pay interest. Interest is money earned from a borrower to a lender. So you borrow the money, let's say you borrow $100, you got to pay the person you borrowed it back from the $100 plus an interest fee. So if they charge you 5%, then you would pay them back $105. If you lend money, then you would earn interest by charging the person that borrowed money from you interest. Interest rates are often expressed in tenths of a percent. So I wanted to show you what that looks like. For example, if you charged 5.7% interest, what would that look like in a percent in a decimal? Well, that's the same thing as saying 5.7 over 100, because it's per 100. And 5.7 divided by 100 is 0.057. You can find that using a calculator, or you can say, you know what, I'm just going to move my decimal 2 places to the left. There's nothing here, so I have to put a placeholder. So 5.7% is 0.057 as a decimal. Because percents are ratios, you can solve percentage problems using proportions. For example, What is 25% of 500? I can solve this using a proportion. I would take my 25% and I would write it as a fraction, because remember, a percent is per 100, or a ratio with a denominator of 100. Now, if I wanted to know if that number would, instead of being 100, was 500, what would the 25 be in order for these to be equivalent? I would put an X up there because I don't know. Then I would cross multiply. 500 times 25 is 12,500. And 100 times X equals 100. If I divide both sides by, or 100X, sorry. I'm solving for X, so I divide both sides by 100. And when I do that, I get 125 equals X. So, 25% of 500 is 125. This is a fairly simple way to solve it, but there's an even easier way to solve percentage problems. Because percentages can be rewritten as decimals instead of just fractions, I think it's quicker to solve it as a standard equation. So what I'm going to do is I'm going to take this red statement and I'm going to rewrite it into blank percent of blank is blank. Now in this case, I'm going to fill in my blanks. 25% is what we have here. So 25%, or I can write it as a decimal, 0.25, of means to multiply, of 500 is, that means equals what? I don't know what that is. So I can solve for that question mark, or I can solve for that X. So I can rewrite this as 0.25 times 500 equals X. And when I multiply 0.25 times 500, I get 125 equals X. This is the way that I do it. Your book gives a different formula, but it's very similar to the one that I use, and both of them are derived from the original proportion. The book says percent times base equals number. The base is the original number, the 500, and the number, the N that they use, is the result, and that would be 125. When I solve the problems, I'm going to use both because I think that will make everything clearer for you. There are 3 basic types of percent problems, and we're going to solve one of each as an example. If you will look on page 6 at example 1, that is going to give our first type of percent problem. It says find the percent of a number. So what we're missing is the number. It says if 58% of 800 radios were sold during the first week of a sale, how many radios were sold? Well, we know the percentage. It's 0.58, so I'm going to put that in place of my percent blank. Of is times. I do know my original or my base number, which is 800. That's how many I have. I want to know how many of those I sold. I don't know what it is, so that will be my variable N. And when I multiply 0.58 times 800, I get 464. So in this case, I solved for the number, and it is 464 of the original 800 units were sold. The next kind of problem I'm going to solve is when we find what percent one number is of another. If you will look on page 6 at example 2, it says, what is the percent grade of a road that rises 900 feet in 10,500 horizontal feet? Give your answer to the tenth of a percent. So I don't know what my percent is. So that's what my N or my variable is going to be, because I don't know. And then my base, the original, is 10,500. What percent of 10,500 is 900? I think using this top one, percent of blank is makes it easier to understand what goes where. What percent of 10,500 is 9? Well, I have to divide both sides by P, and I get, or both sides by 10,500 to solve for P, and I get 0.086. That is a percentage written as a decimal. I want it to be written as a percent, so I'm going to convert it by moving my decimal place 2 places to the right, because remember, when we turn a decimal into a percent, we're multiplying by 100. So my percentage is 8.6%. There's an 8.6% increase. The last kind of percent problem we're going to solve is when we find the base or the original given the percent a number is of that base. If you will look on page 7 at example 3, it says the Jaegers spent 24% of their annual income for rent last year. If they spent $1,250 per month for rent, how much was their annual income? Well, we know the percentage. We know what percentage we spent of the original or of their annual income, but we don't know what that is. So we're going to put 0.24 in place of percent. We do not know what our annual income was, so that's our base, but we do know that 24% of it is 1,250. And so now we're going to solve for B by dividing both sides by 0.24. And when we do that, we get 62,500. So that their annual income was 62,500. 24% of 62,500 is 1,250. We are going to solve a few of these problems together before we end. I would like for you to put these in your notebook, and whatever we do not solve together, I would like you to finish and show me when you come back to class next time. The first problem is what percent of 44 is 23? I don't know my percentage, so that's what is going to be my variable. What percent of times 44 is equals 23. I divide both sides by 44 and I get P equals 0.523. That's a decimal, not a percent. I need to turn it into a percentage by moving my decimal 2 places to the right, and when I do that I get 52.3%. Problem 2 says what number is 19% of 64? Well, I know my percent, so I'm going to put that, 0.19, in place of that. Of 64, I know my of, so I'm going to put 64 here, equals what number? That's my n, that's my variable. All I have to do is multiply 0.19 times 64, and I get n equals 12.16. In problem number 3, 35% is 72% of what? 35 is 72% of what number? I don't know what my base is. 72.72 is my percent. Of, I don't know what my of is. That's my B. But I do know that my number is 35. So I'm going to have to divide both sides by 0.72. And when I do that, I get my B, my base, or my of, as 48.6. So 72% of 48.6 is 35. I would like you to do the last 3, number 4, 5, and 6 on your own and bring them to class. We're going to skip to number 8. The unemployment rate for the U.S. is 4%. If there are 5,655,000 unemployed people at least 16 years old in the U.S., how many people in the U.S. are at least 16 years old? Well, I'm going to go to my original formula and I'm going to say 4% of, I don't know what my of is 5,655,000 people. That is going to translate into 0.04 for my P. I do not know my B, that's my variable, is 5,655, or 5,655,000. When I solve for this, I divide both sides by 0.04, and I end up getting B is 141,375,000. That's a huge number. I'd like to look at number 9 now. 9 says how many are employed? Well, out of the 141,375,000 people that are employed, 5,655,000 are not. So to solve, all I have to do is subtract my 141,375,000 minus 5,655,000, and the result is 135,720,000 people are employed. Please finish problems 7 and 10 in addition to the others and bring them to class to show me next time you come.